Second shell, it will be
It will be 4.
4.
Then what is the valency for carbon?
Yes, ma'am.
What is the valency for carbon?
Um, 12.
What?
The value for carbon is 12.
Valency. Valency of carbon is what then? What you were saying? You were saying
4.
12. You were saying
Valence
12?
of carbon is 4.
Valency of carbon is 4. Then we have read 2 types of bonds. One is ionic bond. Another is what? One is ionic bond and another is
Covalent bond.
covalent bond. Yeah. Okay. Then which type of bond do you think carbon would make?
It's ionic.
Ionic bond and covalent bond. What ionic bond in what was happening in ionic bond? In ionic bond, carbon was completely like not carbon. Let's say whatever atom we have, let's say random atom X. In ionic bond, it completely gives one electron and it become positively charged, and the other one take that electron and it become negatively charged.
Yes.
Give me one second.
Yes, ma'am.
Hello. Hello.
Yes, ma'am.
Yeah, and in covalent bond, what happens in covalent bond? Let's take carbon. It shares the electron with some other molecule. Now, what we are going to learn today, we are going to learn then one thing I will tell you that carbon makes covalent bonds. Because to make ionic bonds, carbon need to leave 4 electrons, right? 1,
Yes.
2, 3, 4, right?
Yes, ma'am.
See, like for ionic bond, what carbon has 4 electrons in the outermost shell. 1, 2, 3, 4. So it has 2 options. Either it can take 4 more electrons, 1, 2, 3, 4, 5, 6, 7, 8, or it can leave these 4 electrons and it can have the inner shell which is 2 electrons, right?
Yes, ma'am.
But this 2 electron won't stabilize carbon, and adding 4 electrons, that would be too much high energy that this thing will not be stable anymore, okay? Like
Yes.
C4 minus, this won't be stable at all. Then
Yes, ma'am.
what option is left for carbon? The option left for carbon is making 4 covalent bonds.
Yes.
So what happens? Carbon has 4 electrons in the outer shell. And what hydrogen has? Hydrogen, how many electron hydrogen has?
One.
Hmm?
One.
One. So
Yes.
hydrogen needs 2 electron to get stabilized, okay? Because hydrogen is so
Yes.
small, it doesn't need 8 electron. It needs 2 electron to get
Yes.
stable. So let's say we can take 4 hydrogen and this hydrogen and this carbon can share 1 electron, 2 electrons, 2 electrons, 2 electrons, 2 electrons, right?
Yes, ma'am.
Thus, carbon also gets 8 electron and hydrogen also gets its 2 electron. And this gets very stable. So here we have 1 carbon and 4 hydrogen. Hence, the formula for this will be CH4, right?
Eight. Yes, ma'am.
CH4, 1 carbon, 4 hydrogen.
Okay.
So, okay. Now, we are entering our organic chemistry part. So, CH4 is the simplest organic compound. Okay. And what is it called? CH4 is called methane. Now we will come to it later that why it is called methane and we will learn the nomenclature too. As of now, CH4 is the simplest organic compound. So how many bonds one carbon atom can make? 4 bonds.
Four bone.
4 bonds it can make, and if those 4 bonds are made with 4 different hydrogens, then we will call it methane, which is our simplest organic compound.
Yes, ma'am.
Now, you remember that we have learned sigma bond, we have learned p orbitals
Yes, ma'am.
in the last class,
Yes, ma'am.
px, py, and pz,
Yes.
right?
Yes, ma'am.
Yeah. So what carbon has? Carbon has these p orbitals, okay? These p orbitals are the outermost orbitals for carbon. I know these things are a bit little tough, but it's fine. You don't have to remember it this way. You have to remember what the conclusion will be. What we are
Yes.
going to learn now, that is sigma bond and pi bond.
Why not?
You have any idea what is sigma bond and what is pi bond?
Sigma bond like no, ma'am.
Hmm?
No, ma'am.
Okay. So what is sigma bond? And see, hydrogen has s orbital and s orbital is spherical. Carbon has p orbital, so which is like this, like 2 balloons, right? Now, when carbon is bonding with hydrogen, then it this is the bond for hydrogen and this is for carbon.
Yes.
This is for carbon. This is p orbital. Now, when these two mix, bond is made this way. Okay, this is the s orbital. This is the p orbital. Okay,
Ma'am.
and thus we get the Hc bond.
Yes.
Now, hydrogen has spherical s orbital, so only one type of collision is possible, right? Let's say we
Yes.
had this s orbital, this and this p orbital, these two came closer and they made this bond, which is our Hc bond.
Yes.
Because of hydrogen atom having spherical orbital, spherical s orbital, only one type of collision is possible. Now, let's assume that the carbon is bonding with another carbon. Now, what was the outermost shell for carbon? That was p, right? So now this can happen in 3 ways. these two can come closer. These two can come closer,
Yes,
or
ma'am.
these two can come closer, right?
Yes.
Now, when these two are coming closer, you see,
They're
this is
attached to it.
called head-on collision. Like these are having the collision face to face, right?
Yes, ma'am.
This is happening face to face. But when the other twos are taking place, like this and these,
Yes.
or these and these, you see, these two are not happening face to face. These are happening side by side, right?
Yes, ma'am.
So when this face to face collision
Ma'am, for
happens,
this one,
this
like
cause
the like slanting attached to it are like side by side or face to face.
what?
This for the last one, like you did not do. For the first one, it was side by side. Second one was face to face. What about the third one? Is it side by side
Third
or
one is
face
also
to
side by side. This is also side by side. You see, no? These are side by side. No? This case and this case are similar almost. Right?
face? Yes.
This is also side by side. This is also side by side.
Yes.
So when it's happening side by side, the side by side collision, this results into less stronger bonds. And this is also less stronger bond. And this face-to-face collision leads to strong bond. Okay. Now this face-to-face collision is known as sigma bond. The side-by-side collisions are known as pi bonds. Okay. All right.
Yes, ma'am.
Okay. Now how to understand that which one is pi bond and which one is sigma bond? So remember, if there is only one bond between two atoms, that is the sigma bond. Okay.
Yes.
The first bond that like let's say hydrogen and carbon we have, there is only one bond, right?
Yes, ma'am.
So the first bond that we get, that is the sigma bond.
Big mom.
And the first bond form, that is due to the head-on collision. Okay, that is the
Yes.
face-to-face collision.
Yes.
Now what I told you that these three px, py, and pz, these are oriented in 90 degree, right? In three axes, x, y, and z.
Yes,
So
ma'am.
if this is the now let's say this head-on collision has taken place between these two. Now how the other two will be oriented? It will be oriented like this, right?
Yes, ma'am. Yes, ma'am.
Now you see already when the head-on collision had took place, these two are already oriented side by side.
Yes.
So if there is any more bond formed after that, then that will be pi bond. Okay?
Yeah, for like sigma bond, it will be a single one, right? And for carbon, it will be double.
Yeah, if there is only one bond, that is sigma bond, and if there is more than one bond,
So it
then
will be pi.
it's pi bond. Like if I give you now I give you an example. Let's say we have this compound. Now can you tell me how many pi bonds are there and how many sigma bonds are there?
Um, it's like actually three, so it's actually pi bond.
No, it's not like that. It's like here are three bonds, right?
Yes, ma'am.
Between three bonds, how three bonds are formed? First one bond is formed, then another bond, and then another bond, right?
Yes, ma'am.
This is how 3 bonds are formed. The bond that was formed first, that is the sigma bond. And after the first bond is formed, then the other bonds are pi bonds.
Five.
Okay.
Two.
Yeah.
Okay.
Let's say this is our z axis, and let's say this is our y axis, and this is our x axis, this is our y axis. Then this is pz. So the sigma bond is formed due to head-on collision of pz orbitals, right?
Yes, ma'am.
After that, this is pz, pz. After that, px and px came side by side closure, and py and py2 came side by side closure. Those two resulted into formation of pi bond. Okay.
Yes, ma'am.
So if there is 3 bonds, then one has to be sigma bond and the others are pi bonds. So similarly, if there are 5 bonds or so many bonds, doesn't matter how many bonds are there. If there are n number of bonds, then one is sigma bond and n minus 1 numbers are pi bonds. Okay?
Yes, ma'am.
Okay. So let's do another example. Okay. First, let's check if all the carbon has 4 bonds. Let's name this 1, 2, 3.
Three.
So how many bonds the first carbon has?
First carbon has 2 bonds, so it's pi
How 2
bond.
bonds? You are not considering the CH bonds. There are CH bonds too, right?
Yes.
So you have to consider total how many bonds the carbon has. It has
Three.
one, two,
Two. Three.
three, four.
Four.
Here
Four.
it is a double bond, right?
Yes, ma'am.
Here are double bonds, here are 2 bonds, here is one, and here is one. So this carbon, the first carbon has 2 bonds.
Two
So how
bonds.
many bonds the second carbon has?
Second carbon has 4.
4 bonds. Here it has 1, 2,
Two.
3,
Three.
4,
Four.
right?
Yes.
Okay. How many bonds the third carbon has?
Um, 4.
How?
1, 2, 3,
Hmm.
4.
1, 2, 3, 4. And the
Yes.
fourth carbon has also 4 bonds, right? 1, 2,
Four.
3, and 4. Okay. Now you will tell me that in the whole compound I have given you, like in this whole compound, how many sigma bonds are there and how many pi bonds are there? Okay?
Yes, ma'am. So pi bonds are like 3 and
You said pi bonds are 3.
no, ma'am, wait, okay, 1 minute.
Yeah, sure. Take time and answer. How many sigma bonds in the total molecule? Don't miss any bond, okay?
So ma'am, for pi bond it's 2. I mean 1.
For
I
1,
mean
the
sigma
pi
bond.
bond is sigma
No,
bond is
sorry,
1.
for sigma bond it's 1 and for pi bond it's 3.
For sigma bonds, it's 1 and pi bond, it's 3. You were saying for the first one. That's what you were saying, right?
Yes, ma'am.
Explain me how.
Because pi bond has like one
Hmm?
bond. One bond and like for pi bond it's like more than one bond. It's like
See, how many bonds this first carbon has with hydrogen? This
4.
hydrogen. Let's name the hydrogens too. 1, 2, 3, 4. So,
Four.
how many numbers of bond this carbon has with hydrogen 1?
Hydrogen 1. 4.
How many bonds are there?
2. Oh no, 4.
How 4? I am asking one carbon, this carbon number 1 and this hydrogen number 1. Carbon 1 and hydrogen 1, how many bonds they share?
2.
There's only one bond, right? How you are getting 2? It's only one. One hydrogen and one carbon. There's clearly only one bond, no?
Yes, ma'am.
So if there's one bond, it would be sigma or pi.
Okay. So like the first
I
one
have
is
told
like
you, there is only if they, yeah, the first one is sigma. If there is only one bond, that is sigma, right? So this bond is sigma bond. Now, how many bonds one carbon and two hydrogen are sharing? Like hydrogen number 2 and carbon number 1, how many bonds they are sharing? Here,
2.
how you are getting 2? They are sharing 2 electrons, but 2 electrons makes one bond, right?
Yes, ma'am.
So there is only one bond. I
So
have drawn one line. Come on, where you are getting 2 bonds? Can you explain me once?
no, actually it's between carbon. There's 2 lines. So I'm thinking that I'm taking that only as like shared electrons.
You are? No, repeat what you said.
Like the line like between carbon 1 and carbon 2, there's like 2 double bonds, right? Like lines. So they're sharing it.
Yeah, that's between carbon 1 and carbon 2. But I am asking carbon 1 and hydrogen 2. How many bonds they are sharing?
1.
One bond. So this is sigma bond or pi bond?
It's pi 1. No,
Pi
it's
bond.
sigma.
I have told you. It's sigma bond. It's only one bond between one carbon and two hydrogen. No.
Yes, so
And if
sigma
there is only one bond, it's sigma bond. Now, how many bonds carbon 1 and carbon 2 sharing?
Yes, ma'am.
How many bonds carbon 1 and carbon 2 are sharing?
1 1.
Hmm?
One like one carbon like one they're sharing with
Carbon 1
hydrogen
and
one and
carbon
carbon.
2, they are sharing two bonds. Carbon 1 and carbon 2, they are sharing two bonds. See, I have drawn two lines here. They are sharing two bonds.
Yes, ma'am.
So one of them will be sigma and another will be
Pi.
pi. Okay.
Yes, ma'am.
Now carbon 2 and carbon 3 are sharing how many bonds?
1.
One. So it would be sigma or pi.
Yes, ma'am.
It would be sigma or pi. Carbon 2 and carbon 3, the bond between carbon 2 and carbon 3 would be sigma or would be pi.
No, it's pi sigma.
It's sigma. Now carbon 2 and hydrogen 3. Hydrogen 3 and carbon 2, how many bonds they are sharing?
1.
So it would be sigma or pi.
It will be pi.
If only one bond, it's sigma. So they are
Um,
sharing only one bond, so it's sigma bond.
it's sigma.
Okay.
Okay.
Now carbon 3 and carbon 4 are sharing how many bonds?
3 bonds.
Then one of them would be sigma. And how
And the
many pi
other
will
2
be
will
there?
be
Other
2.
two will be pi's. So here are one sigma and two pi. And carbon 4 and hydrogen 4 are also sharing only one bond, so it would be sigma bond, right?
Yes, ma'am.
So now tell me in total how many sigma bonds and how many pi bonds are there in the molecule.
7 and
Let's
3 pi bonds. 3 sigma bonds and 3 pi
so
bonds.
three pi bonds, that's right. How three pi bonds? Here is one pi bond. Here is one pi bond and here are two
And the
pi
other
bonds.
is 2 is then. And
So that's, and there are so many sigma bonds. How? 3 sigma. 1, 2,
yeah,
3,
its sigma bonds are 6.
4, 5, 6, 7. So there are total 7 sigma bonds. Okay.
Yes, ma'am.
One sigma bond is here, one is here, 1, 2, 3, 4, 5, 6, 7. Right?
Yes, ma'am.
Okay. So let's do another example and you will do this. You understood this, right? So if
Yes,
there
ma'am.
is only one bond, that will be sigma bond, and if there is more than one bond, then one
It will
would be
be
sigma
5.
and the others will be pi. Okay?
5. Yes, ma'am.
Okay. So let's do this. First thing I ask you to check if the valency of all the carbons are fulfilled. Now check the molecule I have given you and tell me if the valency for all the carbons has been fulfilled.
Okay, ma'am. Wait. Ma'am, we have to find out how many pi bonds and sigma bonds are there, right?
No, first tell me if the valency of all the carbons are satisfied.
Okay.
Or we need to add some more bonds to some carbon or to remove some bonds.
Uh,
Check if all the carbon has 4 bonds, if or not.
Ma'am, in the first,
Yeah,
carbon, you forgot to put one more hydrogen. It's supposed to
there
be
is.
4, 3, right? In the first one.
Okay, very good. So we have to add one hydrogen here, right?
And over here, after double bond, there is one extra carbon. We have to remove that. I mean hydrogen.
Okay, let me number. Wait, let me number the carbons. 1, 2, 4, 5, 6, 7. Yeah, now say what we need to do.
In the fourth carbon, you have to remove one more. It's extra hydrogen you have to. And for third one, you have
Okay,
to
very
add.
good.
In
Very
third
good.
one, you have to add one hydrogen.
Okay. Okay, very good. You are absolutely correct. And now you tell me. So first question was that if the valency is fulfilled, and we solved it, right? You were
Yes,
absolutely correct. Now you have to tell me how many sigma bonds are there and how many pi bonds are there in the whole molecule.
yes, ma'am. Ma'am,
Yes.
ma'am, pi ones I got is sigma one I got is 10 and pi one I got 3.
5 bonds, you got 3. Okay, let's count. So we have sigma bonds. Let's count first. 1, 2, 3, 4, 5, 6, 7. There are more than 10 sigma bonds I can see. Count the sigma bonds again,
13 are
okay?
there.
1, yeah,
13 pi sigma bonds are there, right?
30. Okay, 13 you are saying, right?
Yes.
You are saying 13. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there are pi bonds. Here is one pi bonds and here are two pi bonds. So you are
3
absolutely
pi
right
bonds are
about the
there.
pi bonds. You are absolutely right about the pi bonds, but sigma bonds are 16 there. Okay. You see, here
Okay.
is one bond, two bond, three bond, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay.
Yes, ma'am.
Okay. Good. Then do this short example very quick. Yeah. Quickly tell me how many sigma bonds are there and how many pi bonds are there?
Yes, ma'am. 1 minute. Ma'am, 7 pi bonds and 3. No, sorry, 7 sigma bonds and 3 pi bonds.
7 sigma bonds and 3 pi bonds also. Let's see. There is 1, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Okay. Correct. You said 7 sigma bonds and 3 pi bonds. All right. So you understood this concept, right?
Yes, ma'am.
Okay. So moving on. What I said the name for this?
Methane.
Okay. So what would be structure for this?
C and 4
Mm-hmm.
hydrogens. So like C,
Four
yeah,
hydrogen.
hydrogen.
Yeah. So how many pi bonds are there and how many sigma bonds are there?
Only pi bonds are, sigma bonds are 4 and pi bonds are not.
Okay, good. Now, if I try to increase one carbon here, then can you guess what will be the structure?
Yes, ma'am.
If I increase one carbon, like this is
Yes.
CH4, right?
Yes, ma'am.
And the structure for CH4 is
Yeah,
Okay, let's do it properly. Yeah. Firstly, we have methane, which is CH4, and structure for this is carbon and 4 hydrogens.
yes, ma'am.
After this, what we will have, let's say here we have only one carbon, right?
Yes, ma'am.
Now we are adding another carbon to this. So hydrogen can have only one bond, right? It's not like we can add one carbon this side and another carbon this side of hydrogen. This is not
Yes,
possible,
ma'am.
right?
Yes, ma'am.
Okay. So if we try to add one carbon, we have to add it with, like we have to bond it with another carbon only. So the structure of this will be, and how many hydrogen will be there in total if there is one carbon-carbon bond? How
8,
many hydrogens we need now?
8.
Do we really need 8?
No, ma'am,
Think
6.
of it. And then 6, right? This need 3. And the other one also needs 3, right?
Yes, ma'am.
Now both the carbon has 4 bonds. See, why not 4? Because this bond is already getting satisfied by another carbon, right?
Yes, ma'am.
Okay. So what is the formula for this? C2H6.
C2H6.
Name for this will be
Ethylene.
ethane. Okay.
Then become butane.
Hmm? Yeah, you
Then
said
it
it
will
correct.
become
Say it again.
propane. The third one will
It
be
will be
propane.
propane.
So it
Do
will
you
be
know why it would be propane?
propane
Okay. Then what would be the formula for propane?
C3H8.
H8. Correct. Then we will have, I am not drawing the structure anymore. Then we will have, after propane, we will
Butane.
have butane. After propane, we have butane, which is C4H10.
H10.
Then we will have pentane,
Pentane. C5H12.
C5H12.
Then we have,
Then we
it will be C6H14.
have C6H14. Then
Heptane, we have C7H16.
mhm,
Then we have octane, C8H18.
have octane,
Octane, we have C8H18.
H18.
18.
We will
Then we
go up
have
to 10.
nano, nano,
No none.
nonens. Then we have C9H20. Then we have decane, C10H22.
Then H22.
22.
Very good. Now all of these compounds we have written here,
Yes, ma'am.
like all the compounds we have written here from methane to decane, all these are known as alkanes.
Alkenes. Now we have alkenes.
Al C alkanes. Why
Alkenes.
alkanes? If you see all the names here, it had butane,
Yes,
pentane, hexane,
yes,
heptane,
ma'am.
octane, nonane, decane. Similarly, here we have methane, ethane,
Ethane.
propane, right?
Yes, ma'am.
So all these are known as alks. Let's say alk, and all these are anes.
Yes.
Why anes? When there is only single bond.
Single.
That means only sigma bonds,
Yes.
no pi bonds. As in, no double or
Or triple.
triple bond. Then it would be anes. Okay.
Anes.
Then the suffix we will add, that will be ane.
Ane.
A-N-E-N. Okay.
Ane. Yes, ma'am.
And if there is double bond,
So we will write alkene.
yeah, double bond means how many pi bond?
2. I mean 1.
Double bond implies one
Yes.
sigma, one pi.
Yes,
That
ma'am.
we will call
Alkene.
alkene. Okay. This ene is for one sigma, one pi. Okay.
Yes. And
And
it's for
after that, when we have
triple
triple
bonds
bond
of
means how many?
alkynes.
Alkynes.
So
Triple bond
two
means how
pi.
many pi bonds? Two pi bonds. One sigma and one pi. Those are called as alkynes. Right?
Yes, ma'am.
So this ine is for one
Triple
sigma,
bond.
sorry, two pi.
1 sigma, 2 pi.
One sigma, two pi. This is for ines. Okay. If that's for ines now. Now coming to, if there is only one carbon, let's write this. 2 carbon, 3 carbon, 4 carbon, 5 carbon. So when we had only one carbon in our alkane series, what we called it? Like we had CH4. What we called CH4 as?
Methane.
We called it methane. We called it
Methane.
methane, right?
Yes, ma'am.
When we had two carbon, which was C2H6, we called it ethane.
Ethane. If we have three carbons,
Hmm? We
C3
called it propane.
and 8 propane.
For 4, we called it
Butane.
butane. For 5 carbon, we called
Pentane.
it
Pentane. And for the 6,
pen.
hexane.
So you are understanding that this in part came because there was only one sigma bond. That is, there were
Yes,
no
ma'am.
double
Yes.
bonds or triple bonds. For that,
Yes.
this in part came, and this meth, eth, prop, but, pent, this part came depending upon the number of the carbon. Okay.
Yes.
So we will make one box now. How to turn this ruler? Do you know how to turn this ruler?
Ma'am, you can make it 30 degree or 45 degrees actually. Turn it to 30 degree and
How?
ma'am, I have
But
no idea.
how?
Ma'am, you can press on 45 degree.
No, it's not working.
Ma'am, you can use the shapes.
Oh, it happened. Wait. Where's the shapes?
Know that
This is the
lines,
shape.
the triangles, shapes, and all this comes right. So you can from there you can take line. So it will be easier.
Insert. Oh,
Draw,
we have
ma'am.
table. We have table. I got it.
Draw.
I got the table. So table. Oh, the table is not working.
Ma'am, you can check it on draw.
In the draw option, there is no shape. This is something else. No, this is some order. 1 7. Just give me 1 second. Okay, leave. Let's just do it. Okay, we have enough space. Yeah, we have enough space. So what we are going to do, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. And here we have 1 sigma, no pi, 1 sigma,
Ma'am, you can go on that paint, so might be over there options might come for to draw and all this.
which one?
Paints. This is paint.
Paint.
Yeah, paint. This paint.
It's the color only.
The options are not there. Something will be answered.
Okay, okay, fine. Let's do 1 carbon, and here we have no pi, 1 sigma. That is single bond. Okay.
Yes, ma'am.
Single bond. Then we will have 1 pi, 1 sigma. That is double bond. And then we will have 2 pi, 1 sigma, which is triple bond. Right? Now, what was our prefix for 1 carbon? It was meth, right?
Yes, ma'am.
Hello? Yeah, it
Yes, ma'am.
was meth. For 2 carbon, it was eth. For 3
Pro,
carbon, it was
then
pro.
view, pen, and hex.
Or then we had bu. Then we
Pen
had
and then hex.
pen. Then we had and what was our suffix for single bond? It was ane, right?
A. For double bond,
It
it
was
was A. E. For
it was
triple bond, it was ein.
for triple bond. It was yeah. For triple bond, it was I. So if we have only 1 carbon and only single bonds, then what we would call it? We
Yes,
would
ma'am.
call it, if we have only 1 carbon and single bonds only, we will
So it
call
will be
it
methane.
methane. Meth
Methane.
from here, ane from here. Okay.
Yes, ma'am.
Now, if we have 1 carbon, now let's do this first. If we have 2 carbon and only single bonds, what we will call it?
Ethane.
Eth.
Ane. then propane.
Now come here. If we have one carbon and we have double bond, that is one pi bond and one sigma bond, what we will call it?
Methane, 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 methane.
Methane. But, if we have only one carbon, right?
Yes, ma'am.
We have to use only one carbon.
Yes,
Then this carbon would form the double bond with whom? We can't use another carbon. We can only use hydrogens, right?
yes, ma'am.
But can hydrogen form double bond?
No, ma'am.
Hydrogen can form only single bonds.
Yes, ma'am.
So we need to use another carbon to create a double bond, isn't it?
Yes, ma'am.
But if we do that, that won't be myth anymore. That would be it. Right?
Yes, ma'am.
If we use another carbon, there will be two carbons in total.
Yes, ma'am.
So that won't be myth anymore. That would be it. So only one carbon and double bond, this doesn't exist. Okay?
Yes, ma'am.
Because when we are having only one carbon, we can only use hydrogens.
Yes, ma'am.
To create double bond or triple bond, we need at least one more carbon.
Yes, ma'am.
Okay? So double bond with double bond with only one carbon, or double bond with triple bond with only one carbon, this doesn't exist. Fine?
Yes, ma'am. Yes.
Okay. So this doesn't exist and this doesn't exist. Okay?
Yes, ma'am.
Now what it will called when there is two carbon and only one double bond?
Two carbons and one double bond. So it will be ethane. Ethene.
Ethene. Ethene.
Ethene.
And two carbon and one triple bond, it would be ethylene. Okay?
Yes, ma'am.
Right?
Yes,
Then three carbon and one single bond, it would call
propane.
propane. Three carbon and one double bond,
Propene.
propene. Three carbon and one triple bond,
Propine.
propine. Then here it would be butane. It would
Butane.
be butene. And it would be butine. This is the ine and this is our but. So it would be butine. Then we
Yes,
have pentane,
pentene and pentane.
pentene and pentine. And here we'll have hexane,
Hexene. Hexane.
hexene, hexine. Now, what was the formula for methane? The formula for methane was CH4, right?
CH4. Yes, ma'am.
CH4. Okay.
CH.
It was CH4. Formula for ethane was
C2H6.
H6. Propane
C3H8. C4
C3H8. Yeah.
H10.
C4
C5
H10.
H12. C6 H14.
C6 H14. Now can you tell me that what will be the formula for ethane? Ethene.
C2 H4.
How did you say C2H4?
Because I applied the formula.
Yeah, tell me how you will write this.
Over here it's C2N18. It will be C2H6, right? So 6 will minus it with 2. So the answer, it will be 2 then. I mean
Yeah,
4.
like there will be two double bonds between carbons. Between two carbons, there will be two bonds. So this carbon has left two more bonds, and this carbon has left two more bonds.
Yes, ma'am.
So here it's H, 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 H. So there are two carbon and four H. Okay.
Now wait, but ma'am,
Similarly, yeah,
what about the
yeah, say.
only? Oh no, wait, sorry. I
It's
was
okay.
yes, ma'am.
Okay. Okay. Now for propene, oh,
C3H6.
C3H6. Correct. But how? How many? We will have only one pi bond. Okay. So
Yes,
propene
ma'am.
will be like this.
Yes, ma'am.
See carefully. Propene won't be like this. Okay.
Yes.
Propene will be
Only one
like
at one
this.
place double bond will take
Yeah.
place.
Only one pi bond we will have, not two pi bonds. In this case, we are having
Yes.
two pi bonds, right? But in the whole molecule, we will have only one pi bond. So if this be our, yeah, if this be our carbon, then it would have two hydrogen,
Yes, ma'am.
it would have one hydrogen, and it would have three hydrogen. So
Yes,
3 and 3 total will be 6, right?
ma'am.
Okay.
So it will be C3H6.
Yeah, it will be C3H.
H6. Then for butane, it will be C4H8.
Mm-hmm. Yes, 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 say.
Then for propane,
Yeah, for propene, it should be C3H6.
H6. Then it will be
Butane,
C4H8, C5H10, C6H12.
C6H12. Now coming to ethylene, what will be the formula for this? It will have
Um,
three bonds
C,
between carbon, and here one hydrogen, here one hydrogen.
yes, ma'am.
So what will be the formula? It will be C2H2.
H2. Then C,
Oh.
C3H3,
C3H4.
H3.
No, see here. If carbon, only two pi bonds, so two pi bonds are done here. Then, sorry, it's carbon. This will be the carbon chain. Then it will need only one hydrogen. It won't need any hydrogen, and it will need three hydrogen, right?
Yes, ma'am.
So here are three carbon and four hydrogen. That
Yes,
is
ma'am.
C3H4. Then for butane, let's draw the structure here. For butane, what we will have? We will have carbon. We will have, give me one second. Yeah. For butane, it would be carbon, For butane, how many carbons will be there?
At 6,
How many carbon? For butane, there will be 4 carbon, right?
4 carbons and
Yeah,
6 hydrogen.
yeah. 4 carbons and 6 hydrogen. So here it will be like 4 carbons. Now it will have only 1 hydrogen. It will have 2 hydrogen and it will have 3 hydrogen. So 4 carbons and 1, 2, 3, 4, 5, 6 hydrogens. So this would be for butane. C3H6. For pentane, it will be C5H. Sorry, C.
Yes, ma'am. For pentene, it will be C5H8, and for hexene, it will be C6H10.
H10. Okay. Now, seeing those structures, can you give me any common formula for alkyne, alkene, and alkane?
Ma'am, the
Let's say for alkane, let's say follow the trend. It's CH4, C2H6, C3H8, C4H10. So if I tell you,
yes,
if
ma'am.
it's Cn, number of carbon is n. If it's Cn, then what will be the number of hydrogen? What will be here? Can you tell me from this trend?
Like,
Looking
ma'am,
at this trend,
common, like, I can
yeah,
see is like methane and ethane because hydrogen is being same over there 4 4, and propane also hydrogen is 4. So hydrogen in 3 of them.
hydrogen is
Ma'am,
in
you want
methane,
common
ethane, and
hydrogen, right?
propane.
Or common carbon also?
No, I am asking that, see, follow this methane, ethane, propane, butane, pentane, hexane. Okay.
Yes,
It
ma'am.
is CH4, C2H6, C3H8,
Yes, ma'am.
C4H10. So can you follow any trend? Like if I tell you to make out a common formula out of these for
Common
alkyne,
formulating. In
what it
which
will
3
be?
of them is being used?
This, then this, then this, this, this. So you see, when the number is 1, the number of carbon is 1, the number of hydrogen is 4.
Yes,
Okay.
ma'am.
Number of hydrogen 2, then number of carbon 2, number of hydrogen is 6. Number of
Yes, ma'am.
carbon 3, number of hydrogen is 8. So if the
Yes.
number of carbon is n, I say, the number of hydrogen will be 2n plus 2.
Yes, ma'am.
You see, put what I said, that CnH 2n plus 2. If
Yes,
we
ma'am.
say n is equal to 1, the number of carbon is 1. Now from the formula, tell me what will be the number of hydrogen? If n is equal to 1, then what will be the number of hydrogen?
2. Like, no, wait. 4.
It will be 4.
Yes, ma'am.
How? Then 2n will be
Because
2 and 2n plus 2 will be 4.
4.
If n is 2, if n is 1, it's 4. If n is 2, then calculate from here what will be this? It will be 2 into 2, 4 plus 2, that is 6,
8.
right?
6. Yes, ma'am.
6, not 8. If n is 3, then it will be 2 into 3, 6 plus 2, 8,
It will be
right?
8. Yes, ma'am.
8. So can you see this, that this is similar to this? Here when it is 2, it's 6, when it's 3, it's 8, right?
Yes, ma'am.
So the common formula for alkane, we will say CnH2n plus 2. Okay.
Yes, ma'am.
Now can similarly, following the trend for ethene, like alkene, can you give me a common formula?
Common formula like CnH2n.
Like CnH2n. Perfect. Because when it's 2, it's 4. When it's 3,